Hi and welcome to a short demo on sPLINK, a federated, privacy-preserving tool as a robust alternative to meta-analyses in genome-wide association studies, aka GWAS. But first, let me give you a brief introduction on GWAS. GWAS tests millions of single nucleotide polymorphisms, so-called SNPs, to identify possible connections between a specific SNP and disease. In a typical GWAS, samples are either case, with a disease, or control, without the disease. GWAS compare the frequency of an allele in a SNP among case and control samples. A significant difference in allele frequencies over case and control samples signals a possible association between the corresponding SNP and the disease. In a more systematic approach, GWAS data consisting of SNP values, confounding factors, e.g. age or gender, as well as phenotypes, which can be case/control or quantitative, is given to an association test such as chi-square, linear regression, or logistic regression. The association test computes a p-value for each SNP. If the p-value of a SNP is smaller than a pre-specified significance threshold, there is a significant association between the SNP and disease. Studies show that larger GWAS sample sizes lead to identifying more associations and more accurate genetic predictors. The trivial method to increase the sample size is to pull the data for a collaborative GWAS to one central server. However, this is very challenging or even impossible because of privacy concerns and privacy protection laws such as the European GDPR. The meta-analysis approach protects the data privacy by combining the summary statistics from different cohorts and estimating the p-values, but it is not robust against data imbalance and heterogeneity. Meta-analyses lose accuracy if the data has heterogeneously been distributed across the cohorts. Now, sPLINK combines the advantages of a meta-analysis and an aggregated analysis. sPLINK preserves the privacy of cohorts data, since the private data never leaves the site, and only model parameters, e.g. Hessian matrices, are exchanged between the cohorts and the central server. sPLINK is also robust to data heterogeneity. That is, sPLINK always returns the same p-values as an aggregated analysis, independently of the phenotype or confounding factor distributions across the cohorts. The sPLINK system consists of a web interface, a server, and client applications running on the local machines of the individual cohorts. To conduct a privacy-preserving collaborative GWAS, the coordinator initiates a new study, also called project, and invites a set of cohorts to participate. The cohorts, in turn, join the study and select the dataset they want to contribute to the study. After all cohorts have joined, the federated computation of the results starts. The coordinator and the participating cohorts can access the results when the computation is done. In sPLINK, all data traffic is sent through a secure channel using the HTTPS protocol, and the cohorts can use Linux distributions, Microsoft Windows, or macOS to run the client application. For demo purposes, I, Julian, will be the coordinator and a participant running the sPLINK client on Microsoft Windows. Reza will be the other participant using Ubuntu Linux to run the other client. Reza and I host different splits of an example dataset containing 60 samples, 100 SNPs, as well as age and sex as confounding factors. I will use logistic regression as the association test in the demo. So much for the introduction. Now let's get started with the actual demo. In order to start using sPLINK, we first need to create a user account. Make sure that you choose a username with at least 3 characters and a password with at least 6 characters. You will need to enter these credentials later in the client application, so make sure not to lose them. After sign up, you will be taken to the Projects page, where you can start creating a project right away. At this point, there is 3 different association tests available: logistic regression, linear regression, and chi-square. We will be using logistic regression in this demo. Next, we need to enter a name, which helps to identify the project later. Next, we can enter confounding factors. They are essentially column names which need to match those contained in the conf file that you will provide the client applications with later. They need to be the same across all cohorts. Chunk size is a parameter that influences running time. Roughly speaking, the larger the chunks, the faster, but the less stable the run will be. If you're unsure what to choose, just leave it at 100K. The max number of iterations specifies an upper limit for the number of iterations per chunk to be used for reaching conversion. Normally conversion is reached after about 5 iterations. We will stick with the default of 20 for this demo. After clicking Create, you will be taken to the project info page. Here you can see the parameters again, and you can see which participants have already joined. Right now, there is no participants yet. In order for participants to join, you first need to create so-called tokens. These tokens can be regarded as access keys that allow other participants to join the project. Reza, our other participant, is already waiting for the token, so I need to pass it to him. Let's switch to Reza's screen now, so that you can see how he uses the token to join the project. After starting the client application, you first need to enter the user credentials. These are the very same that you used to sign up for sPLINK. Then you need to paste the token that you received from the coordinator. The project coordinator can see which participants have joined by observing the user column. It will change from unused to the user ID once the token has been used to join the project. After joining, each participant needs to provide the client application with a bat file containing the snip data and a conf file containing confounding features. By clicking Run, you indicate that you are ready to start the computation. Click the Show Log button to view more detailed information about the project progress. Alright, one participant is ready now, but since we have created 2 tokens, we need another participant for sPLINK to start the computation. In this demo, I will be the other participant. It is perfectly okay for the coordinator to also be a participant. So I will now do the very same thing that Reza did before, the only difference being that I'm on Windows and that I have a different split of the data. Since you already know the procedure, I will accelerate this a little. Now that both participants have clicked Run, the actual computation starts off. You can monitor the progress and the current status by observing either the client log or the log in the web interface. The computation can take a while depending on how large the data is and how many participants you have. Let's again accelerate this a little until we have the results. Okay, when the computation is done, you will get notified by the client, and you can also see it in the web interface. The clients will automatically download a file containing the results, including the snips, their p-values, and other information. In the web interface, you can see a Manhattan plot showing the significance of the individual snips by plotting the p-values. You can also download the results file from there. I hope you found this video helpful. If you have questions, don't hesitate to contact us. You can find the contact information on the About page. Thanks for watching.